Well, thank you very much. Good afternoon. Thanks for coming and joining us on this session on continuous compliance and open source. My name is Rinat Shagisultanov. My current role is a VP of Technology at consulting company InfoMagnus. I'm joined today by my colleague Troy Sabin, Chief Architect. He and I worked on this project together. I'm here to talk about the pressing challenge in the modern software development. How do we maintain safety compliance when our critical systems increasingly depend on open source software? Today we'll explore the practices, actionable strategies for implementing software bill of material or SBOM-Driven traceability. And I'll show you the specific workflows that you can implement right away. This is based on the learnings while working with my colleague Troy Sabin on the open source continuous compliance platform that is intended to be a reference implementation for the upcoming SPDX 3.1 safety profile. While this work is still in development, there are tools and practices that we feel that you can apply today, and we feel it is prudent to share with you within the scope of the conference. So I know there are only we have few of you, but nevertheless, let's start with a quick show of hand. First, who here works with an open software in the safety critical systems? Can you raise your hand? Okay. Great. That's quite a lot of you. Second, who struggles to maintain compliance in modern agile or DevOps workflows? Raise your hand. Okay. And third, who here manages the open source projects that you know are being used in safety critical contexts? Raise your hand. Okay. That's important because today we'll address both sides of the equation. So consuming open source and maintaining open source standards in the complex systems. So here's the paradox that we're facing. According to the Linux Foundation 2022 study, the modern software solutions compose of approximately 70 to 90% of free or open source components. And according to the research that was mentioned in the keynotes on the day one by Black Duck in 2024, 97% of the companies are using open source software. We heard more from Frank Nagel, again in the keynotes, about the economic impact of open source, and which is remarkable, 8.1 trillion. But our safety processes were designed for the era of the waterfall development and proprietary closed source systems. The result isn't just compliance bottlenecks, it's innovation bottlenecks that slow everything down. Development teams are waiting weeks for compliance reviews. Open source projects avoid safety critical domains because of an overhead it seems impossible. Everyone loses. That's where we're here to fix. The numbers across the industries are staggering, and they represent both opportunities and responsibility in automotive. For example, Toyota and Honda running Linux and Android automotive platforms, they becoming standards. Boeing planes and SpaceX spacecrafts are running Linux for critical functions. But here's the reality. The fact that we're using open source doesn't mean that safety standards disappear. These standards weren't written for the distributed development and continuous integration. So you need to bridge the gap. And today we'll show you how. So if you think about the various acronyms, CI, CD, CT for continuous testing, think about adding another two-letter word, continuous compliance. ELISA and SPDX are two Linux Foundation projects that provide key pieces for the continuous compliance puzzle. ELISA, or Embedded Linux in Safety Applications, its goal is to make Linux systems suitable for the safety-critical systems. But many tools, patterns, and processes that are in the scope of ELISA project can be broadly adopted for all open source software used in regulated industries. The other project mentioned here, SPDX, or Software Package Data Exchange, aims to standardize how we share metadata, describe and communicate the composition of your software. The term is called SBOMs. So the SBOMs are critical for licensing, security, and software compliance. Both projects, ELISA and SPDX, are supported by a very large and diverse community from industry and open source domains. Together, they provide standards, practices, and tools needed to meet the rigorous demands of the functional safety and compliance across industries. And they are the foundation on which our continuous compliance platform is built. Before we dive deeper, it's important to understand how these pieces are fitting together. At the base, we have SPDX 3.1 and its safety profile, the open standard for the data. Building on that, we have ELISA and its tools like BASIL, which provides the utilities to define traceability relationships and generate SBOMs that are annotated with this critical safety information. Our project, Open Fuser Functional Safety Continuous Compliance Platform, or simply CC, sits on top. It acts as an automation and orchestration layer. It consumes the safety annotated SBOMs, integrates with tools like BASIL, and provides the continuous SBOM change impact analysis, policy evaluation, and compliance reporting that turns the raw data that you receive in your software development process into the actionable compliance intelligence. Let's dig deeper into the safety annotated SBOMs based on a 3.1 standard, since they are fundamental enabler of continuous compliance. Most people think about SBOMs as a sort of a manifest or that has a roster of simple components from which your software is built, together with vulnerabilities detected in it. That's SBOM 1.0 thinking. SPDX 3.1 safety profile will transform SBOMs into the compliance-ready documents. Safety annotated SBOMs tell you what's safety critical, which standards apply, and link directly to the verification evidence. This isn't just better documentation. It enables automated compliance assessment. The upcoming SPDX 3.1 model will standardize safety annotations through the safety profile, but you don't have to wait for the 3.1 to be released. What you can do, you can take the existing SPDX 3.1 standards and use its extension mechanism currently today. This is what ELISA's BASIL application product does today, which we will discuss in a moment. SPDX relationships are the key for traceability. By combining them, you can build machine-readable traceable chains from requirements to code to test and to test results. Tools can traverse this graph to perform impact analysis. For example, if requirement changes, what code and tests need to are affected. It can help you identify the gaps in verification. For example, requirements without a test case or a test case without the result. As well as, third, it can support automated compliance evidence generation. For example, to show the coverage of ASIL-related requirements. The tool that I mentioned earlier today, it's called BASIL. It is an ELISA's open source software quality management tool that let us define the critical relationships mentioned in the previous slides. It turns scattered safety artifacts into a live SPDX controlled knowledge graph. So giving us exactly the fuel for the continuous compliance pipeline needs for automate proofs and keep releases audit ready. So its key capabilities include single source of traceability. This includes the web UI and REST API that lets team map and visualize every user artifact relationship in one place. That means requirements, tests, hazards, justification, and others. Second, it contains the built-in gaps completeness analytics. BASIL shows % of coverage, highlights missing links, and updates impact analysis whenever a requirement or test changes. Third, it supports a test execution awareness. It integrates with the CI/CD pipeline and test runners to pull results back into the trace model. Number 4, BASIL today is, sorry, I don't know why it's switches off. Number 4, BASIL tool supports SPDX Model 3 today. And with one click on the UI or the API call to the tool, you can produce design-level SBOMs with all trace links. So perfect for machine-readable evidence for the downstream checks. And I also would like to mention the main creator of the tool. So his name is Luigi Pelliccia, and he's an active member of the ELISA project. So why BASIL matters for continuous compliance? In every CI run, we can call BASIL API to export the fresh SPDX 3 SBOM with the safety annotations. Our continuous compliance platform ingests that said SBOM, applies the FUSE policies, and decides to pass or block the deployment. ASIL and the acronym that I've used earlier today, ASIL, stands for the Automotive Safety Integrity Level, which is part of the ISO 2622 standard. Here is where the SBOM-driven traceability becomes transformative for risk management. In practice, our platform can perform an automated diff between SBOMs. When we talk about diffs, usually what comes in your mind is probably doing the diff at the source code level. SBOMs are complex structures, and when we talk about the diffs and SBOMs, we talk about semantic diffs. When a component changes, the platform that uses its dependency graph and multi-hop traceability to instantly identify what is the impact. It can then see the components like the component if, for example, if component is ASIL-D traces to the specific safety goal and is verified by certain tests and policy analysis. Our objective with the tool is that instead of days of manual work, the right artifacts are flagged for review in minutes. And this is how you can mitigate the change impact analysis at the speed of the modern DevOps. This workflow that you see at the top is the heart of the continuous compliance. On every code commit, an SBOM is generated and annotated. It is then sent to the compliance platform, which identifies safety-relevant changes and runs the automated assessment against a set of context-aware safety policies. If the policies pass, the pipeline proceeds. If not, the build is gated and the alert is sent with the detailed findings. And you can see the examples of what these policies are right here on the screen. I've discussed some of the key enablers of the continuous compliance, but let's step back and look at the bigger picture. These are the foundational building blocks that can turn your compliance from the periodic and manual headache into the continuous and automated signal that flows with every commit. I don't want to mention the beaten up phrase about shifting left, but that's exactly, if you look from continuous compliance, completeness, really exactly that's what we're doing. First, the safety annotated and version SBOMs. Everything starts with a software bill of material that isn't just a flat ingredient list. We enrich each component with a functional safety metadata, ASIL safety mechanisms, evidence links, and we version the SBOM the same way as you do the version of the code. That gives us the authoritative timestamp snapshots for every release the CI run. Second, fuse a traceable graph, fuse a traceability graph. We express the classic V-model traceability requirements to design, to implementation, to tests as a graph that lives inside the SBOM. Nodes are the artifacts and the edges are the links. Graph queries let us answer the questions such as, for example, show me all code paths that satisfy ISO 26222-4 clause 5.4 instantly. SBOM-Diff and impact analysis engine, which is the number 3 item here, is when we pull requests, when the pull request lands, we diff the current SBOM against the previous one. The engine flags only the delta, so like new packages, updated versions, or the deleted files. It assesses the impact, the safety impact. For example, that you changed MCU driver touching a high ASIL path, and triggers just the test and evidence regeneration that you need. Policy and test automation engine. Policies like, for example, no GPL-3 in bootloader are codified as rules. The engine will evaluate them on every build, and if a rule fails, it will auto-generate the test case or a compliance check required, integrating with your existing test frameworks. The orchestration engine is the conductor. It's a heart. It sequences SBOM generation, diff, policy checks, and evidence collection inside the CI/CD pipelines. Think about GitHub Actions, GitLab, Jenkins, whatever you use, so that compliance stays in a lockstep with the DevOps. Our vision of the continuous compliance is to have a framework accompanied with a CLI tool on top of that. And CLI tool, if you can run headlessly, you can integrate it with a great variety of tools. We're also thinking that integration hooks are really required. We integrate directly with the CI/CD systems to automate SBOM ingestion and compliance gating. Bidirectional sync with your ALM and issue trackers enables traceability that flows both ways. With our REST API, CLI tools, and outbound webhooks, the teams can automate and monitor compliance in real time. Last but not the least, it's reporting and analytics. The dashboards that surface the compliance status, coverage gaps, and the violations, traceability completeness is still needed. Because we have versioned SBOMs, we can then trend the matrix over time, which is great for audits and for demonstrating continuous improvements. With these 7 capabilities working together, compliance becomes a first-class automated outcome of everyday development rather than just a fire drill at the release time. Looking ahead, everything that we've discussed so far sets the foundation for the next evolution, AI-enhanced compliance. This is where we're heading. Imagine the following. A developer copilot that not only generates the code, but does so with the MISRA-C and relevant industry safety standards in mind, providing real-time compliance feedback. Real-time and editor feedback can then warn of the potential safety implications. Pull requests can be assessed against the safety standards and policies. Same way as you're doing today with the regular CI pipelines that are showing up in your pull requests in GitHub. We're moving from the reactive checks to the predictive risk assessment, where the AI models can analyze historical data and dependency patterns to forecast which components are most likely to fail or cause compliance issues. I'd like you to refer to one of the sessions from yesterday that was speaking about how to detect that green deployments doesn't mean that you have successful system in production. Think about the manual effort of creating traceability links. Automated traceability discovery uses AI to read your requirements, documentation, and your code to suggest those links automatically. And finally, empowering every stakeholder with a natural language policy engine. Safety managers right now, or potentially, could simply ask, what's blocking our ASIL-C compliance, and get the immediate and actionable answer. This is the future as we see it of making safety compliance not just continuous, but also intelligent. Now let's talk about some general practices to help you with the successful continuous compliance implementations. SBOM evolution is a huge practical challenge. Using semantic versioning, just as you do with the code, will help. Establish the golden baseline, which means compliance-approved snapshots for each release. Use automated diffing that compares not just the SBOM content, but also the results of the compliance policies against each version. This will tell you if a change actually impacts the your compliance posture or not, and have a clear strategy for contributing safety metadata upstream. Open source governance for safety is about balancing the community needs and with safety requirements. The key insight is making safety metadata valuable for the project itself, not just for the downstream consumers. Start with incremental adoption, involve maintainers and policy design, and be clear about liability. Open source contribution doesn't imply safety certification, which means that if you're an OEM or the tier 1 supplier, your job is still required. Downstream integrations remain responsibility for validation. Here are actionable integration patterns. First is the key is progressive adoption. Start with the pre-commit hooks, then implement stage gates. In development, the continuous compliance platform might only issue warnings. In QA environment, it will block non-compliant builds. And for production, it will fail the deployment entirely. These dashboards aren't static. The key feature is storing historical compliance results to track trends. For release, the system can then snapshot the compliance state, providing a timestamped, reproducible record for audits. The SPDX 3.0 specification is stable today, and it's ready for the use. Tooling, however, is still maturing. There are some gaps that we discovered in the past 4 months as we started working on the project and the code. But they are surmountable with a bit of an effort. As part of the open source community, you can help close these gaps. You don't need to wait to get started. So you can take significant steps towards the continuous compliance with tools that are available today. Choose one immediate next step. If you're not generating SBOMs yet, start there. If you already have basic SBOMs, integrate simple compliance gates. The key is starting small and building experience. By gaining experience and maturing your processes today, you'll be much more prepared to get maximum benefits from the SPDX 3.1 safety profile and its specs, as well as the OpenFuse continuous compliance platform when they become available. This is the short overview opinionated of the use of the open and open source tools in the regulated industries such as automotive, embedded, and IoT. First of all, this slide highlights robust open source and open ecosystem across automotive, embedded, and IoT domains. Sorry. It showcases the diverse tooling and platform stacks available today, built explicitly to leverage hardware and software. The application, the middleware mentioned here, includes is targeted for automotive, embedded, and IoT contexts. And this includes the systems and projects that are already mentioned in this conference. Automotive-grade Linux, Zephyr real-time operating system, as well as the open standards such as AutoSAR. Virtualization layer includes the hypervisors such as Zen that provide secure virtualization environments that are critical for isolated and dependable automotive and embedded applications. And cloud infrastructure that exists today is based on the Kubernetes OpenStack, as well as the that offering suggested by Sophie, enables agile and scalable cloud-native automotive and IoT deployments. And finally, the tier that is DevOps or CI/CD and test tooling, that's where we spend a lot of time today. Includes the tools such as GitHub Actions, Jenkins, security frameworks provided by OWASP, and others. Linux build tools such as Yocto, Buildroot accelerate development of customized embedded Linux distributions optimized for your specific hardware needs. And finally, again, another node to the ELISA BASIL project included into the DevOps tool chains. Why it matters? Because integrating the open source tools and open standards accelerates innovation and development velocity, while you can leverage the community expertise and rigorous safety standards compliance. The use of open standards ensures compatibility, security, and performance across the diverse applications. And one of the last slides in our session is focused on the implementing OpenFuSE continuous compliance. Here I'm highlighting how OpenFuSE CC platform fits into the open source DevOps lifecycle, specifically emphasizing the automation and functional safety compliance. So this includes the SBOM and SPDX 3.1 safety profile that I spoke about earlier, integration with the DevOps lifecycle. Again, if you learned about 3 acronyms, CI, CD, and continuous testing, you may as well start learning the 4th one, which is the CC, continuous compliance. And finally, the open source ecosystem collaboration. This includes projects that are supported by Linux Foundation, Eclipse, and Sophie. So why it matters? Because the automated compliance reduces manual overhead, significantly accelerates development cycles, and enhances system reliability and audit readiness. So far, we've been focusing on the software, but at the same time, the automotive, embedded, and IoT have both the software in the loop and hardware in the loop. And the approach that we're tackling applies to both both swim lanes in the product development. The key takeaways. So first, start small and scale fast. Second, balance community needs with the compliance requirements. Third, automation is absolutely necessary. Finally, the foundation exists today, you don't have to wait. The slide deck that is attached will be updated with the links that are relevant for the project. That's a nod to the ELISA and SPDX development communities. And if you want to take a snapshot of the LinkedIn profiles for myself and for Troy, as well as the company that we're working for, please do so. Thank you very much.